What if I told you that time, the very thing you live by, might not even exist the way you think it does? The ticking of your clock, the rising and setting of the sun, the calendar pages that fall away one by one. What if all of that is just an illusion? Every moment you've lived, every dream of the future, every memory of the past, they may not be what they seem. Time could be stretching, bending, or even flowing backwards, and you wouldn't even notice. Tonight, we're going to step into the secret life of time. But before we begin, pause for a second. If you want to keep uncovering mysteries that no one explains this way, make sure you subscribe right now. Because once you start this journey, you'll never look at time or your life the same way again. Time. We speak about it as if we understand it. We say, don't waste time. We say, time heals all wounds. We say, the past is gone, the present is now, the future is waiting. But have you ever stopped to ask, what is time really? To a child, time moves slowly. An hour feels like an eternity. To an adult, the years fly by as if they were days. If time is supposed to be fixed and universal, why does it feel so different depending on who you are, where you are, and even how you feel? Scientists try to measure it. They build clocks. They calculate the movement of planets. They define seconds with the vibrations of atoms. But none of this truly explains what time is. All it does is count it. But to count something doesn't mean you've understood it. Einstein once shattered our idea of time when he showed us that it is not absolute. Time is woven together with space, stretching and bending with gravity, moving differently depending on speed. To him, time wasn't a rigid river flowing forward. It was a flexible fabric, capable of twisting in ways our minds can hardly imagine. And then, there's the strangest mystery of all, your brain. The way you perceive time has less to do with clocks and more to do with memory, attention, and even emotion. That's why a moment of joy seems to vanish in an instant, while a painful night feels endless. In truth, the time you experience may not be the same as the person sitting next to you. So is time a thing? Or is it just an illusion, a story our minds tell to make sense of change? This is the mystery of time, something we all live inside, yet cannot touch, cannot see, and perhaps cannot even fully define. It slips through our fingers like water, and the more we chase it, the more it escapes. And that is where our journey begins. Close your eyes for a moment. Imagine you are living in the 1800s. The world is simpler, or so it seems. Trains connect cities, telegrams send words across continents, and the most brilliant minds of the time believe they already understand the universe. Time, in their eyes, is simple. Like the steady beat of a drum, it ticks away. The same for everyone, everywhere. It flows forward, never backward, steady and absolute. The clock on the wall and the clock in the sky, the sun, were thought to be in perfect agreement. But then, a quiet, unassuming clerk in a Swiss patent office begins to ask questions no one else dares to ask. His name, Albert Einstein. The old view of time for centuries, scientists believed in what Isaac Newton described, an absolute time. Newton imagined time as a vast invisible stage, stretching endlessly into the past and future, on which the drama of the universe unfolds. The stage is fixed, unmoving, unaffected by what happens upon it. But there was a problem. The more carefully scientists measured the universe, the more cracks began to appear in this idea. Light, especially, refused to behave the way Newton's universe demanded. Experiments showed that no matter how fast you moved toward or away from it, light always traveled at the same speed. How could that be? Shouldn't motion change how quickly light appears to move? The puzzle grew, and with it, doubt about the very nature of time itself. Einstein's radical idea. In 1905, Einstein published a paper that would forever change our view of the cosmos. His idea was bold, almost unthinkable. Time is not absolute. According to Einstein, time does not beat with the same rhythm for everyone. Instead, it bends, stretches, and warps depending on your speed and gravity. What feels like a second for you might not be a second for someone else moving at incredible speed. Two people can live through the same events, yet experience different durations of time. This was not just philosophy, it was testable, measurable, and it shattered everything people thought they knew. Imagine two twins. One remains on Earth, the other travels through space at near the speed of light. When the traveling twin returns, they are younger than the twin who stayed behind. This is not fantasy. It's called time dilation, and it's real. Einstein revealed that time and space are not separate things at all, but part of one grand fabric, space-time. Gravity itself is not a force pulling objects together, but the bending of this fabric. The stronger the gravity, the slower time flows. So when you stand at the bottom of a mountain, time runs a little slower for you than for someone standing at the top. The difference is tiny, but real. The shock wave of relativity. At first, many scientists resisted. How could time, the very foundation of existence, be relative? Yet experiment after experiment confirmed Einstein's vision. In 1919, during a solar eclipse, astronomers proved that starlight bent around the sun exactly as Einstein's equations predicted. Overnight, the unknown patent clerk became a global icon, his wild hair and deep eyes forever linked with the mysteries of time and space. The world was forced to accept a new truth. Time was not the steady, universal drumbeat people imagined. It was elastic, flexible, alive. Time in everyday life. You might think, this is fascinating, but what does it matter to me? Here's the truth. Without Einstein's relativity, your GPS would not work. The satellites orbiting Earth experience time slightly faster than we do on the ground because gravity is weaker up there. If engineers ignored this, GPS signals would drift by kilometers each day. The reason you can find your way to a friend's house or a hidden cafe in the city is because scientists learned how to adjust for the stretching and bending of time. So every time you check your phone for directions, you are using Einstein's theory. You are touching the secret life of time itself. The human side of Einstein. But what made Einstein's idea so powerful was not just mathematics. It was his way of seeing. He was not a traditional scientist. He did not always rely on heavy equipment or elaborate labs. Instead, he used his imagination. He once asked, what would it feel like to ride on a beam of light? That question became the seed of his revolutionary theory. He thought in pictures, in dreams. And in doing so, he revealed that time was not the cold, rigid structure we thought it was. It was dynamic, woven into the fabric of reality, connected to energy, motion, and space. The deeper mystery. Yet, as much as Einstein explained, he also left us with questions. If time bends, stretches, and slows, can it break? Can it stop? Can it reverse? Relativity opened doors to strange possibilities, wormholes, time travel, and cosmic horizons where the laws of time itself may collapse. Scientists still wrestle with these questions today, building on the path Einstein began. And as we look deeper into the universe, into black holes and the edges of the cosmos, we find that time may not be what we think at all. A pause for wonder. Think about it. The seconds ticking on your clock may not be the same as the seconds ticking on a satellite orbiting Earth. Your heartbeat, your memories, your very sense of self, all are tied to a river of time that flows differently in different places. So when you feel that a moment of joy ends too soon, or a painful moment lasts forever, remember, time has never been simple. From the smallest human feeling to the largest galaxies in the universe, time is slippery, elastic, and mysterious. Einstein did not just give us equations, he gave us a new lens through which to see reality itself. And this, dear listener, is the birth of modern time, a universe where clocks disagree, where twins can age apart, and where every tick of your watch connects you to the bending fabric of space-time itself. But as strange as this may sound, our journey has only just begun. Because if time can bend and stretch, what other strange effects might it hold? And what secrets still lie hidden, waiting to be discovered in the ticking silence of the universe? Stay with me as we drift deeper. Close your eyes again. We've walked with Einstein through the bending fabric of space-time, but now, let's take a step into a stranger world, a place where certainty disappears and reality itself flickers like a candle in the dark. Welcome to the world of quantum mechanics, and here, time is not what you think it is. A world without certainty. In our everyday lives, time feels like a ruler. We measure it in seconds, minutes, and hours. We think of it as continuous, flowing smoothly like water in a river. But in the quantum world, the world of atoms and subatomic particles, that neat picture begins to crumble. Imagine you're watching a tiny electron. You want to know where it is and how it moves through time. But the moment you try to measure it, it changes. It refuses to be pinned down. It can be in two places at once. It can leap from one state to another without traveling the space in between. Time here is not a steady beat. It is a flicker, a probability, a mystery. Time is a quantum illusion. Physicists began to realize something unsettling. The equations of quantum mechanics don't actually require time to exist the way we think it does. When you write down the mathematics, the particle doesn't evolve smoothly in time, like a train traveling down a track. Instead, the system exists in a cloud of possibilities, a blur of what could be, until we look at it. It's the act of observation, of measurement, that makes time feel real. In other words, time at the smallest scale might not be fundamental. It might be something that only emerges when we step back and look at the bigger picture, the way a melody emerges from individual notes. The quantum clock. Scientists have tried to build the most precise clocks in the universe, not by using gears, pendulums, or even light bouncing between mirrors, but by using atoms themselves. In an atomic clock, time is measured by the natural vibration of atoms, like cesium or strontium, ticking billions of times per second. These are so accurate that they lose less than a second in billions of years. But when you peer close enough, even atoms vibrate in strange, unpredictable ways. They do not tick smoothly. They jitter. They blur. They exist in probabilities. So what does this mean? It means the very heartbeat of time itself, the smallest tick we can measure, is not steady at all. Beneath the surface, it is fuzzy, unstable, uncertain, the arrow of time and entropy. Here's another mystery. In the equations of physics, Time doesn't really have a direction. If you filmed the motion of particles and then played the video backwards, the math would still work. There's nothing in quantum mechanics that says time must move forward. And yet, in our lives, it does. Eggs break, but never unbreak. We grow older, but never younger. Memories form, but never erase themselves. This forward motion of time is called the arrow of time, and it's one of the biggest puzzles in physics. Some scientists believe the arrow of time comes from entropy, the natural tendency of things to move from order to disorder. A cup of hot tea cools down, but it never spontaneously heats back up. In this way, entropy may be the hidden engine pushing time forward. But even this explanation feels incomplete. Because when we look at the quantum level, entropy doesn't always behave the way we expect. Sometimes, systems can reverse themselves, momentarily breaking the arrow of time. What does that mean for us? Could time, under the right conditions, actually run backwards? Time and the quantum universe. There's another possibility. Some physicists believe time itself is not fundamental at all. Instead, it may be an illusion that emerges from the entanglement of particles. Entanglement is one of the strangest features of quantum mechanics. Two particles can become linked so deeply that even if you separate them by galaxies, a change in one instantly affects the other. Now imagine the entire universe as one vast web of entanglement. Some scientists suggest that what we call time is simply the unfolding of this web, the gradual revealing of information as particles interact and become entangled with each other. In this view, time is not a river flowing from past to future. It's a story being written as the universe reveals its secrets, moment by moment. Time and consciousness. Here's where it gets even stranger. Some thinkers suggest that our own minds may play a role in shaping the flow of time. When we measure a quantum system, we collapse probabilities into a single reality. In that sense, the act of observing is what creates a definite outcome. But what is an observer? A human being with a mind, living through seconds and minutes. Could it be that consciousness and time are intertwined? That without minds to measure, to witness, to remember, there is no flow of time at all? It's a haunting thought. Maybe time is not a property of the universe, but a property of the way we experience it. The unfinished puzzle. Quantum physics has given us breathtaking power. Lasers, computers, smartphones, medical imaging. All of it rests on the strange rules of the quantum world. But when it comes to time, we are still standing at the edge of a great mystery. Is time fundamental, woven into the fabric of the cosmos? Or is it an illusion, a trick of perspective, a shadow cast by something deeper? Einstein showed us that time bends and stretches. Quantum mechanics suggests that time flickers, dissolves, and may not even exist in the way we imagine. And yet, here we are. You, listening. Me, speaking. Both of us moving through what feels like a shared moment, a fragile miracle of perception. A gentle drift. Forward. So as you breathe slowly, drifting into thought, imagine the quantum universe beneath you. Atoms shimmering, particles vibrating in clouds of probability, time itself pulsing in uncertain beats. Maybe the clock on your wall tells you one story of time. But deep down, beneath the ticking, the universe whispers another story. A story where time is not fixed, but fluid, fragile, and perhaps just an illusion. And as we journey deeper, the mystery only grows. Because if time is uncertain in the quantum world, what strange effects might ripple through the universe at large? Stay with me as we uncover more. Close your eyes and imagine you're standing at the edge of time itself. Before you, a path stretches in two directions. Behind you lies the past, filled with all the moments that made you who you are. Ahead of you, the future waits, shimmering like a mirage you can't quite touch. We move forward, always forward. But what if that rule could be broken? What if you could walk back into yesterday or leap ahead into tomorrow? This is the dream of time travel, a dream older than science, older than physics, woven into myths, stories, and human imagination. But could it be real? The seeds of the idea. Long before scientists debated it, people dreamed of time travel. Ancient myths spoke of heroes who slept for 100 years and awoke to a changed world. Fairy tales whispered of magical clocks that could rewind the hours. And later, writers like H.G. Wells made it vivid with the time machine, a contraption that carried its passenger through centuries like a train on invisible tracks. But here's the question. Is time travel just fantasy, or could physics allow it? Einstein's gift. Time is flexible. We return, once again, to Einstein. His theory of relativity shattered the rigid picture of time. He showed that time is not absolute. It can speed up, slow down, or stretch depending on how you move and where you are. Imagine two twins. One stays on Earth. The other boards a spaceship traveling close to the speed of light. When the traveling twin returns, she finds her sister much older than herself. This isn't science fiction. It's time dilation, a proven effect of relativity. In this way, we already know that time travel into the future is possible. Not with magical machines, but with speed and gravity. Astronauts aboard the International Space Station orbiting Earth experience time just a little slower than we do. They are, technically, time travelers, though only by a fraction of a second. So the future is open. The harder question is, can we go back? The paradox of the past. Traveling to the past is where things get messy. Think of the famous grandfather paradox. If you went back in time and prevented your grandfather from meeting your grandmother, you would erase your own existence. But then, how could you have traveled back at all? This logical loop is one reason many scientists believe backward time travel is impossible. Yet some daring theories suggest it might not be. Wormholes, the cosmic tunnels. One possibility lies hidden in Einstein's equations. Wormholes. Picture space and time as a sheet of paper. If you fold the paper, two distant points can touch. A wormhole is like a tunnel connecting those points, a shortcut through space-time. In theory, if you could create or find a stable wormhole, you might be able to connect not just two places, but two times. Step into one end, and you could emerge in the past or the future. The problem? Wormholes are unstable. They collapse before anything can pass through. To keep them open, scientists believe you would need exotic matter, a form of energy with negative mass, something we've never discovered in nature. It's as if the universe teases us with the possibility, but guards the door with impossible locks. Time loops and closed. Time-like curves. Another strange concept is called a closed time-like curve. Imagine space-time twisted in such a way that your path loops back onto itself. You could start at one moment, travel forward, and eventually arrive back at the very same moment you began. This idea exists in solutions to Einstein's equations, but whether such loops can exist in reality is unknown. Some physicists argue that nature has a built-in safeguard, something called the chronology protection conjecture. In simple words, the universe may not allow paradoxes. If you try to build a time machine, the laws of physics might always conspire to destroy it before it works. Quantum hints of time travel. But then, at the quantum level, things become stranger. In quantum physics, particles sometimes behave as if they can move backward in time. Certain interpretations of equations, like those involving antiparticles, hint that what looks like a particle moving forward could also be seen as a particle moving backward in time. Physicists have even experimented with quantum simulations where information seems to retrace its steps, echoing backward. While this isn't time travel in the way we imagine, it shows that the rules of time are more flexible than we once believed. The emotional weight of time. But let's step away from equations for a moment. Ask yourself honestly, if time travel were real, where would you go? Would you go back to relive a childhood moment? To say goodbye to someone you lost? To stop yourself from making a mistake? Or would you leap forward to see the future of humanity, to witness what becomes of Earth, to know whether the dreams of today are fulfilled tomorrow? Time travel is not just a scientific puzzle, it's an emotional longing. It reflects our deepest desire to rewrite what we regret or to know what lies ahead. Perhaps that's why the universe withholds it from us. Perhaps time travel is not meant for us, because part of being human is learning to live with what is past and to hope for what is to come. The mystery remains. So, can we travel through time? The answer is partially. We already do, every day, moving into the future, 1 second at a time. With speed and gravity, we can push that forward, stepping ahead by years in just moments. The past, however, remains a shadow. Theoretical wormholes, closed loops, and quantum tricks whisper possibilities, but none have crossed into reality. And yet, the dream will not die. As long as we wonder, as long as we imagine, the possibility of time travel will live in the human mind. A gentle drift. So tonight, as you drift deeper into thought, imagine a doorway, hidden somewhere in the stars, a passage through space-time, waiting to be found. Maybe, in another universe, you've already stepped through it. Maybe another version of you is walking in the past or gazing into the future. Or maybe, just maybe, the greatest journey through time is the one we are already taking, here and now, moment by moment, heartbeat by heartbeat. And as we move forward, together, we carry the most powerful machine of all: memory, imagination, and the ability to dream. Think of your life as a movie. Every frame plays in perfect order. You wake up, you breathe, you move, you speak, and never, not once, do the frames reverse. A glass may slip from your hand and shatter into countless pieces. But have you ever seen those pieces jump back together, whole and unbroken? That is the mystery of the arrow of time, the reason life flows in only one direction, forward. The flow. We cannot escape. We humans feel time as a river, always moving, never stopping, never turning back. But here's the question: why? Physics tells us that the fundamental laws of the universe, at the smallest scales, are almost perfectly symmetrical. If you reversed them, ran them backwards, like a tape rewinding, the equations would still make sense. So why doesn't reality behave that way? Why don't we see broken glasses reassembling, smoke drifting back into a candle, or ourselves growing younger instead of older? The answer lies in one of the most profound concepts in science: entropy. Entropy. the key to time's arrow. Entropy is often described as disorder, but more accurately, it is the measure of how many ways something can be arranged. Think again of that broken glass. When it is whole, there are very few ways for its atoms to be arranged. But once it shatters, the pieces can scatter into millions of possible patterns. The universe prefers disorder because there are simply more ways for things to be disordered than ordered. This tendency, this pull toward greater entropy, is what gives time its arrow. Every second, the universe shifts into states that are more probable, more spread out, more chaotic. That's why heat flows from hot to cold, why energy dissipates, why memories pile up behind us, but not ahead. Entropy is the silent hand that pushes time forward. The cosmic clock. This isn't just about broken cups or melting ice. The arrow of time stretches across the universe itself. Billions of years ago, the cosmos was born in the Big Bang, a state of unimaginable density, but surprisingly low entropy. Since then, entropy has been increasing as stars burn their fuel, as galaxies collide, as matter spreads thinner and thinner across the expanding void. One day, far in the future, entropy will reach its peak. Stars will go out, black holes will evaporate, energy will be evenly distributed everywhere, with no difference left to drive motion or change. Physicists call this the heat death of the universe, a final silence where time's arrow may no longer have meaning. It sounds bleak, but it also means that the arrow of time is not just about clocks ticking or calendars turning. It is woven into the destiny of the cosmos itself. The human side of the arrow. And here is where it becomes deeply personal. You and I, we live inside this arrow. We cannot escape it. We are born, we grow, we age, and we move toward the end. Memories only form in one direction, behind us. You remember yesterday, but not tomorrow. You see the past written in your life, but the future remains hidden, waiting. The arrow of time is not just physics. It is the fabric of human experience. It is the reason nostalgia hurts, the reason hope exists, the reason stories can only be told from beginning to end. Could the arrow reverse? But wait. What if entropy could be reversed? What if, in some distant corner of the multiverse, time flowed backward? Physicists debate this. Some argue that another universe might exist where the arrow points the other way, where beings live their lives in reverse, where death is the beginning and youth is the end. If such a universe exists, we may never meet its inhabitants because our arrows point in opposite directions. But even the possibility makes us wonder, is time truly universal? Or is it just a perspective, something local to our world? The deeper mystery. Here is the haunting truth. No one fully knows why the universe began in such a low entropy state. Why did it start in such improbable order, only to unravel as time marched forward? Some say it is chance. Others whisper that it is design. But whatever the answer, the arrow of time is the reason you are listening to this right now. It is the reason you have memories, the reason you have a future to walk into, the reason life has meaning at all. A gentle drift. So tonight, as you sink into the rhythm of your own heartbeat, feel the arrow of time carrying you forward, not backward, not sideways, always forward. It is a current we cannot fight, but perhaps that is its gift, because every moment that passes is a reminder. This second, this breath, this thought will never come again. The arrow of time is not cruel. It is precious. It is the reason we love, the reason we cherish, the reason we dream. And as long as it flows, you and I are part of something far larger, the great unfolding of the universe itself. Close your eyes for a moment. Forget clocks. Forget calendars. Forget the ticking seconds on your phone. Ask yourself, what is time? Really? Is it a river that carries us? Or is it just a shadow cast by change? Beyond the numbers, science measures time in seconds, minutes, hours. Physics defines it in equations, relativity, quantum events. But deep inside, we all know that time is not just a number. Think of how differently it flows, depending on where you stand. A single night spent waiting for a loved one's message can feel like eternity. Yet hours spent in laughter with a friend vanish in a blink. Here lies the paradox. The universe's time is steady, relentless, cold. But our inner time, human time, is fluid, alive, emotional. Maybe, just maybe, the true mystery of time is not in the cosmos, but in the heart. The human clock. Every human being carries a secret clock within, not the one on the wrist, not the one in the sky, but the one inside the chest. This clock is measured not in seconds, but in moments. Your first memory of childhood laughter, the first time you fell in love, the last goodbye to someone you'll never see again. That clock does not tick evenly. Sometimes it races, sometimes it crawls, but it is always writing the story of who you are. What if the true purpose of time is not to measure the universe, but to measure the soul? Dreams, memory, and the flow. Think of dreams. In a dream, time makes no sense. A lifetime can pass in a few seconds of sleep. Entire stories unfold between two blinks of an eye. And yet when you wake up, you accept it. You never question how a dream could bend time so easily. Isn't it strange? In the dream world, time is not a ruler. It is clay, soft, stretchable, unbound. Maybe this hints at a larger truth. That time, as we know it, is not ultimate. It is not the highest reality. It is just a veil through which we experience existence. The illusion of past and future. The philosopher St. Augustine once confessed, "What then is time? If no one asks me, I know. If I wish to explain it, I do not know." We think of the past as gone. The future is yet to come. But here's the question. Do past and future even exist? The past lives only as memory. The future lives only as imagination. The only thing that ever truly exists is this moment, the eternal now. And yet, we spend our lives running between shadows, regretting the past, chasing the future, forgetting that all along, time has only given us the present. Maybe that is the greatest philosophical drift of all, that we are prisoners of illusions that time itself creates. Time and mortality. Let us be honest. The true reason we feel the weight of time is because it reminds us of mortality. Every tick of the clock whispers, "You will not be here forever." Every birthday candle is not just a celebration. It is also a reminder that your time is being counted. But perhaps this is not a curse. Perhaps it is the greatest gift. Because if time were endless, would love matter? Would moments carry meaning? Would we treasure anything if it could never slip away? It is death that makes life precious. It is time's limit that makes our stories beautiful. Time as teacher. Time teaches in silence. It heals wounds, though it never forgets scars. It reveals truths, though slowly, almost reluctantly. It humbles pride, for no king can defeat its march. And time rewards patience. The seed buried in the soil does not bloom in a day. The caterpillar does not become a butterfly in an instant. The heartbroken soul does not heal overnight, but given enough time, the impossible becomes possible. Maybe that is the hidden philosophy. Time is not against us. Time is shaping us. Cosmic drift. Step back now from human life and look at the stars. Galaxies are born, live, and die over billions of years. To them, our entire civilization is but a heartbeat. And yet here we are, tiny beings, trying to measure eternity with fragile clocks. Isn't that beautiful? Isn't that tragic? If time is the stage, then the universe is the play. We are but actors, entering and exiting, while the drama of existence unfolds across ages we cannot even imagine. And the strange truth is, no one knows who the playwright is, or if there even is one. But still, the play continues, moment after moment, scene after scene. A question that remains. So, what is time? Is it physics, a dimension, a cosmic equation? Or is it an illusion, a trick of consciousness, a shadow that disappears the moment we look too closely? Perhaps the answer does not exist. Or perhaps the answer is too vast for us to hold. But maybe the real purpose is not to solve time, but to live inside it, fully, deeply, gratefully. Because in the end, whether time is real or illusion, this much is true. Once this moment passes, it never returns. Drift into silence. So as you drift deeper into your night, feel the weight of this philosophy, not as a burden, but as a comfort. Time is the river. You are the traveler. And no matter how much we question it, the river carries us gently, steadily, toward places we cannot yet see. Do not fight it. Do not fear it. Float with it. Because maybe, just maybe, time is not your enemy. It is your silent companion, guiding you home. And so, we return to where we began, with a single question echoing in the quiet of your mind. What is time? Maybe it is the ticking of the universe. Maybe it is only a dream of the soul. Or maybe it is both. But tonight, you don't need the final answer. All you need is the gentle rhythm of the present moment. Drifting into silence. Feel your breath, in and out. That's your personal clock, whispering gently, reminding you that you're alive, here, now. As you listen, notice how the questions of science and the wonders of philosophy are no longer heavy. They are simply floating around you, like stars in the sky. Far away, beautiful, untouchable. You don't have to hold them. You don't have to solve them. You just have to let them drift. The lull of mystery. Think of yourself standing at the edge of time's river. You don't need to swim against it. You don't need to rush to the other side. You only need to sit by its banks, listen to the flowing water, and let it carry your thoughts into the distance. Every ripple of that river is a memory. Every wave is a possibility. And every drop is a reminder that life is not measured in hours, but in moments. And in this moment, right now, you are safe, you are calm, you are held. The eternal now. As the seconds pass, they dissolve into silence. The past is already gone. The future has not yet arrived. But this now, this fragile, eternal now, is yours. It is a gift that no one can take away. Close your eyes and imagine the stars above. Some of their light began its journey millions of years ago, only to touch you now, in this instant. Isn't that breathtaking? That across infinite space and time, the universe chose this moment to reach you. A gentle invitation. If you've made it this far, you've allowed yourself to wander through mysteries most people never stop to think about. So maybe this is a sign that your soul is searching, that you're someone who wants more than noise, more than speed, more than distraction. If that feels true for you, then join me again, here, in this quiet corner of the universe. Subscribe, not just to a channel, but to a journey where science and wonder mix with peace and dreams. Because nights are long, and sometimes the mind doesn't want to shut off. But here, you'll always have a place to rest it. Closing the circle. So let us close with this thought. Time is not your enemy. It is your companion, walking with you through every laugh, every tear, every heartbeat. And when you finally rest your head tonight, know that you are not falling into nothingness. You are falling deeper into the mystery of time itself. Let the questions fade. Let your mind soften, and let yourself drift into the timeless silence that has always been waiting for you. Good night, traveler of time. Until we meet again in the next journey.